Hey guys, this is Mrs. Rooker, and I'm going to be doing day 5 with you, which is negative and zero exponents. So the first really important thing is understanding what a negative exponent is. A negative exponent is not a negative number. That's the big important thing. Like, for example, this has nothing to do with being a negative number. It instead means reciprocal. Reciprocal. Which means flip fraction. So if we have, for example, a to the negative b power. What you want to do is you want to take care of the negative. You always want to get rid of the negative. You can't have negative exponents on your answer. To get rid of that, we're going to take this a and flip it to the bottom of a fraction. The exponent stays b, but the negative goes away. And then we don't have anything on the top of the fractions, so we just put a 1. So negative exponent does not mean negative number, it means flip the fraction. Right. And then the next thing, zero exponent, like for example, a to the 0 power. Always, no matter what a is, anything to the 0 power is going to equal 1. And the reason is because if you had like a to the 3rd, I'm just doing an example, over a to the 3rd, remember the rule when you are dividing like bases, like we are here, you're going to subtract the exponents. 3 minus 3 is going to be 0. And remember, when you're reducing fractions, if you have the exact same thing on the top of the fraction as on the bottom fraction, they reduce. Anything divided by itself is just 1, so it reduces to 1. So anything to the 0 power is 1. That's a little bit of a funky one for students to remember, so you just need to memorize it. Anything to the 0 power is 1. All right, so we're going to practice simplifying the following expressions, write answers without negative exponents. So to simplify this one first, all we need to do is get rid of the negative exponent to start, and to do that, we flip the 2 to the bottom of a fraction. The exponent stays 3, but the negative is gone. And then, if there's nothing on the top of the fraction, we just put a 1. And then we simplify. 1 just stays 1, and then we can do 2 to the 3rd power. 2 times 2 is 4, times 2 is 8. And that's our final answer. All right. Next one, we're going to have to do some operations besides just getting rid of the negative exponent. There's a couple different ways you can do this. One way is to just do our normal exponent rules. Right here we're multiplying like bases. So the bases are both 3, we're multiplying like bases, so we add the exponents. The base stays the same. You add the exponents. 5 plus negative 9 is going to be negative 4. But remember, we're not allowed to leave a negative exponent on our answer. So what I'm going to do is I'm going to flip the 3 to the bottom. The exponent is still 4. That negative went away. And then if there's nothing on top, we just put a 1. And then simplify 3 to the 4th power. 3 times 3 is 9, times 3 is 27, times 3 is 81. And again, don't forget you can use calculators on these things if you need help with the multiplying. That was one way to do this one. Also, there's other ways you could do it. You could have, if you wanted to in the beginning, left 3 to the 5th on top of the fraction and flipped 3 to the 9th to the bottom of the fraction to get rid of the negative. And then do your exponent rules, subtract 9 minus 5 is 4, and we get 3 to the 4th on bottom. So that's another way you could have done that one. All right, on this one, remember the exponent rule when you're dividing like bases. So we've got 5 and 5 are the bases. The base stays the same, and you subtract the exponents. I noticed that the 11 is bigger and the 11's on the bottom. So I'm going to do 11 minus 9 and I get 2, but that's going to be on the bottom of a fraction since the 11 was bigger. And if there's nothing on top, I just put a 1. And then to fully simplify, 1 stays 1, and then I do 5 squared. Oops. 5 times 5 is 25. Right. If I'm going too fast at any point in time, you can go ahead and just pause the video to catch up. Alright, so this next one, we have 6 to the negative 2 on bottom. There's nothing really to reduce except for I am not allowed to have a negative exponent, so I need to get rid of that negative. To get rid of the negative, I need to flip this. It was on the bottom of the fraction, the negative exponent, so I'm going to flip it so that it's now on the top of a fraction, and it became positive. I could put it over 1, but that's not really necessary. That just means the same thing as 6 squared, which is 36. So to get rid of a negative exponent, if it's on the bottom of a fraction, you flip it to the top. If it was not in a fraction, or really on the top of the fraction, you flip it to the bottom. Number 5. Again, a couple different ways you can go about doing this. You could, since you are dividing like bases, you could subtract the exponents. I would warn against that though, because you would have to do 5 minus negative 2, and subtracting negatives, a lot of students kind of mess that up. So instead what I would do is probably deal with this negative exponent to start. And to get rid of the negative exponent, I'm going to flip the m to the negative 2 to the top. But be careful, this is already a positive exponent, so that can stay on the top. M to the negative 2 also gets moved to the top, and it becomes positive. Now there's nothing left on the bottom. You can put 1 if you want, but it's not necessary, so I'm just not going to have a bottom. And then I need to fully simplify this. In order to simplify, I need to combine it into m written just once. I'm multiplying like bases, so I add the exponent. So this is going to be m to the 7th power. Alright. So moving on to the next one, whenever I have multiple variables, I just deal with each variable one at a time. So I'm going to deal with just the a's to start, and I'm just going to combine the a's. This a doesn't have an exponent written, so it's a 1. And I'm multiplying the a's together, so when I multiply like bases, I add the exponent. So I'm going to end up with a to the 3rd power. Then do the same thing with the b's. So I have b to the 3rd and b to the negative 4th. When I multiply like bases, I add the exponents. Well, 3 plus negative 4 is basically 3 minus 4, which is going to be negative 1. But again, remember, you're not allowed to have negative exponents in your answer. So I need to flip that b to the bottom. The a had a positive exponent, so it gets to stay on the top. But the b has a negative exponent, so it needs to flip to the bottom. It still has an exponent of 1, which you don't really need to write. It's not necessary to write, but you can if you want to. So either answer is good. Okay, next thing. On this one, we have coefficients as well. So I'm going to deal with the coefficients first. Once I've reduced those, then I'll deal with the w's. Once I've dealt with those, then I'll deal with the x's. So, negative 12 over 15, the coefficients are just normal numbers. I treat them like I would a normal fraction. When I reduce fractions, I need to see if anything goes into both the top and the bottom. 12 and 15, both of those, 3 goes into both of those. So I'm going to divide both of those by 3, and I end up with negative 4 over 5. So that part is done. I'm going to cross it off because I don't have to deal with it anymore. Now I'm going to deal with the w's. First thing I want to do, so I'm just going to write this over here. W to the negative 4 over w squared. I want to deal with the negative exponent. I don't like dealing with negatives, so I'm going to get rid of it by moving that to the bottom. And now the w squared and the w to the fourth are both on the bottom, and I'm going to combine them on the bottom. I'm multiplying them on the bottom. When you multiply like bases, you add the exponent, so we get w to the sixth on the bottom. All right, now I'm going to move on to the x's. We have x to the third over x to the negative 5. I don't want to have to deal with negative exponents, so I'm going to get rid of that first. I'm going to flip this one to the top. So we'll have x to the fifth on top. When we flip it to the top, the negative goes away. Now I have x to the third on top and x to the fifth on top. I'm multiplying them on the top, so I add the exponents. 3 plus 5 is 8. So I end up with x to the 8th on the top. And then I look at this, my coefficients are fully reduced. I only have x written once, I only have w written once, and there's no negative exponents, so I'm done. I'm fully reduced. Alright, moving on. If you guys would like, can you pause the video for me and try problems A, B, and C for me. So pause the video and work on all 3 of those problems, and then when you're back, I will go through them with you. This is the answer for letter A. To get rid of the negative exponent, we flipped the y to the third from the bottom up to the top. Now work on the next 2 and then unpause the video. The answer to B, since I was multiplying like bases, I added those exponents and I got negative 5. And then to get rid of the negative exponent, I flipped the x to the fifth to the bottom. And now work on C and then unpause the video. Here's the answer I got for C. I'll explain it really quick. I would reduce 5 over negative 25 first. They're both divisible by 5, and I get 1 over negative 5. That 1 isn't totally necessary to write, so you don't really need the 1 in front. And then I reduce the a's, so I'm dealing with the a's next. One's on top, one's on bottom, so I subtract the exponents. 4 was bigger, so 4 minus 1 is 3, so we get a to the third on bottom, since the 4 on the bottom was larger. And then same idea with the b's. Next, I reduce the b's. Subtract the exponents, I get b to the second on bottom. And then same with the c's, although the c ended up on top because c to the seventh was larger than c to the fourth. Moving on. Okay, this one's really, really quick. Anything to the 0 power is 1. Memorize that. Anything to the 0 power is 1. It'll save you a lot of time. Okay, next one. We're dividing like bases, so we subtract the exponents. 8 minus 8 is going to be 0. Remember, anything to the 0 power, 1. On this next one, I'm going to simplify the top first. When I'm multiplying these 2 together, I'm just going to multiply the coefficients together first. So negative 7 times 4 is negative 28. And then I'm going to combine the d's. So when I'm multiplying like bases, I add the exponent. So I get d to the negative 8 when I add together negative 6 and negative 2. And then the bottom, I still just have 2d to the negative 4. Got a lot of negative exponents I'm dealing with, so I'm going to flip those to get rid of the negatives. First, I'm going to deal with reducing the coefficients, though. Negative 28 divided by negative 2 is going to be negative 14. And then what I'm going to do is I'm going to flip this to the top and this to the bottom to get rid of the negative exponents so that I'm not dealing with the negatives anymore. Then the final thing I have to do is combine the d's. In order to combine them, I need to subtract these exponents. I get d to the fourth, but it's going to be on bottom since the one on bottom was larger. And that's my final answer. All right, just a couple more. And actually, this one's real quick. First thing I notice, and this is something you should hopefully start to notice, if you ever have something or anything that's raised to the 0 power, it doesn't matter at all what this is. My answer is going to be 1. This whole thing to the 0 power means that whole thing just becomes 1. Right? And then same idea on this one, kind of. I subtract the exponents. I end up with m to the 0 power when I do 7 minus 7, which is 1. Hopefully by the end of this video you will have it very much memorized that anything to the 0 power is 1. Alright, and then the final problem, if you could just pause the video and do this problem really quick for me, and then unpause it and I will go through it with you. Alright, reduce the coefficients. What goes into negative 4 and 16? That's going to be 4. So divide top and bottom by 4. We get negative 1 over 4. Now I deal with the x's. I don't want to have to deal with this negative exponent, so I'm going to flip it to the top. So this is going to be another x to the third on top. So I have x to the third and x to the third on top. So it looks like this, x to the third times x to the third on top. I add the exponents, I get x to the 6th on top. And then I notice that I have y to the 4th on top, y to the 4th on bottom. Anything divided by itself is just 1. Basically, they just cancel. What I could have done is subtracted the exponent and get y to the 0. But remember, anything to the 0 power is just 1. And anything times 1 is just itself. So it's not necessary to have written. So my final answer is just negative 1 or negative x to the 6th over 4. That 1 isn't necessary to have written. Alright, that is it. Thank you so much for watching. Yeah, have a good one.